Alright, so in this recording you're going to see there are two questions that were not on today's review that you probably would like to go over before tomorrow's test. The first question is solving an exponential equation using the method of common bases. You'll notice that the two bases here are 2 and 32. They are not the same. To be able to use this method, we have to create common bases. So the number 32 we know is the same thing as 2 to the 5th power. So now if we make the 32 into 2 to the 5th power, we have common bases. So what I'm going to do over here is rewrite the equation. So 2 to the x to the 4th minus 36 equals 2 to the 5th to the negative x squared. Now that I have my common bases, what I was able to do in lesson 5 was say, well, these bases don't matter. Because they're the same, the exponents have to be equal to each other. So now I can rewrite my equation as just the exponents equal to each other. Notice the right-hand side I wrote as negative 5x to the 2nd power because I'm using the exponent rule of exponents raised to exponents get multiplied together. Now from here we see we have some type of an equation that has exponents in it. But this is something that we would have been able to solve way back when in Unit 1. So I would have set this equal to 0 by adding 5x squared to the other side. So we have x to the 4th power plus 5x squared minus 36 equals 0. And now we could try and factor this. So to factor this, I have to think, well, what multiplies together to make x to the 4th? Well, that would be x squared and x squared. Then what multiplies together to make negative 36, but adds together to make positive 5. So that would be negative 9 and positive 4. Now as soon as I get to this step, I can do one of two things. I can try and factor again, or I could set each equation equal to 0. I see x squared plus 9, that's factorable. So I'm going to make that x plus 3, x minus 3. Those are going to have two real solutions. And then the x squared plus 4, we know that that's not factorable, so I'm just going to leave it as x squared plus 4. So what that's going to allow me to do is say one answer is negative 3, the other answer is positive 3, and the last two answers are going to come from this equation, x squared plus 4 equals 0. Now this is kind of like a throwback question because we haven't done this in a while, but we could see we could subtract 4 from both sides. We have x squared equals negative 4. Then we could take the square root, which gives us answers of x equals plus and minus 2i. So the final answer for this question is plus and minus 2i and plus and minus 3. So there actually winds up being 4 solutions here. Now the next thing that we have to look at that wasn't on the review packet was graphing an exponential function. So if we look at the next question I've come up with here, it asks us about two different graphs. It asks us about the graph of f of x, which is 3 times 2 to the x plus 2, and a graph of g of x, which is 2 to the x, and it asks us to compare both. Before we compare them, let's actually just first start by graphing them. So if I want to graph f of x, I'm going to plug it into my calculator exactly how I see it. So in your calculator, if you were to plug all of that in, you'd be able to go into the table of values and see that you have all of the values that you can graph. Now remember, you're smarter than your calculator, and eventually your calculator is going to start saying number 2 is on your graph, and it's not. The plus 2 here tells us where my asymptote line is. So the function g of x is going to have an asymptote line at 2, meaning the graph's never going to touch 2. And then some valid points that we can use are on my graph, so I'm just going to keep scrolling through. I see one point is 0, 5, so I'll put that on my graph. I see another point is 1, 8, so I'll put that on my graph. Those are probably going to be the only two whole number points I can graph. I might be able to estimate like negative 1, 3.5, but we can see that this graph is going to look something like this. Make sure to put arrows on both sides of the graph and label it as it should. Then if we take the time to go through and graph g of x, since there's no plus or minus, is going to have an asymptote line of the x-axis. We'll see some points on there are like 0, 1, should see 1, 2, should see 2, 4, 3, 8, and you should see it's also a growth function that looks something like this. Again, don't forget those arrows. So you can see these two graphs look very similar to each other. They're just kind of a stretch, a shift. Something happened to get the green graph onto the blue graph. Okay. Now, let's talk a little bit more about f of x before we start talking about the comparison of the two. So f of x has a range that starts at 2 and goes to infinity. Notice I'm using a parenthesis there for the 2 because it actually doesn't touch 2. And if I wanted to describe the end behavior, so x starts by going towards negative infinity, and as we get closer and closer and closer to negative infinity, we're approaching the number 2. So we're going to say f of x approaches 2. And as x approaches positive infinity, so as the graph moves towards the right, the function is getting larger forever, so that's going to approach positive infinity. These are some of the questions I could ask you. These are good multiple choice questions for a test. Now let's describe how f of x and g of x compares. So we can say that g of x is translated up 2, and the 3 is going to be a dilation. Now, because the 3 is outside the function, it's not going to affect it horizontally, it's going to affect it vertically. So we're going to say it has a dilation that's vertical of 2. Now, if this 3 wasn't here, if the 3, say, was 2 to the 3x plus 2, this 3 would actually be a factor of 1/3. But again, that's an if. That's not actually happening in this question. I'm hoping this video helps. I would definitely watch it. And good luck on your test tomorrow.